Afternoon for the launch of the European spacecraft Hera on its mission to investigate what exactly happened at the asteroid that NASA blew a hole in with its DART mission. So, exciting start to a mission. The Hera spacecraft is not going to arrive at the asteroid for another 2 years, almost exactly 2 years. But anyway, has to start somewhere. So I'm joined this afternoon by Michael.
Hello there.
And Daz, how are you?
Hello. How is everyone?
Fantastic. Well, I think we're okay, raring to go, as it were. Very important mission for the European Space Agency, and in lots of ways, quite an innovative mission as well. Michael, have you got any thoughts about this mission?
No, just wish everybody luck on the flight today, and looking forward to a couple of years' time when it actually reaches Dimorphos and Didymos.
Absolutely. So it's quite a long journey. It's going to do a flyby past Mars to pick up some speed in 2025. And then, as we said, arrive at the asteroid at 2026. Now, the whole mission is to investigate the unknowns about the asteroid Dimorphos that NASA slammed a spacecraft into. Why did NASA do that? Well, it's the first attempt at planetary defense to see whether we can actually deflect the path of an asteroid. Now, Dimorphos and its parent asteroid Didymos are not threatening the Earth in any way, so it was just an experiment to see that if an asteroid did approach the Earth and it were dangerous, then what could we do about it? And the mission was a resounding success. But before we go any further, why don't we go over to the European Space Agency for a short video about exactly what this mission is all about.
This is the moment a spacecraft crashed into an asteroid. 2 years ago, NASA made history by intentionally slamming into an asteroid with its DART mission. The asteroid wasn't a threat to us here on Earth, but scientists wanted to see if they could change the path of an asteroid to test a technique that could one day protect us from a real threat. The experiment was a success. Humans can move an asteroid. But the bad news is that scientists aren't sure yet they understand why it worked. There is still a lot we don't know, like what exactly happened on the asteroid's surface after the impact, what the asteroid is made of, and how well the deflection worked. But our Hera spacecraft will soon fly to that same asteroid to answer all of our questions. Hera will perform a close-up crash scene investigation, gathering data on the asteroid's mass, structure, and makeup to turn this kinetic impact method of planetary defense into a well-understood and repeatable technique. Why do we need to protect our planet? In 1908, people reported a bright flash and a noise that sounded like a bomb 10 minutes later. This was from the largest observed asteroid strike ever recorded, which occurred over the Tunguska region in Siberia. People up to 500 miles away reported seeing the flash. Some claimed it was even brighter than the sun. The explosion was massive, causing 80 million trees to flatten, windows up to 250 miles away to smash, and the effects of the shockwave could even be felt in London. This represented a lucky escape for Europe. It happened just a short distance from affecting heavily populated regions. As a result, ESA, NASA, and other space agencies started closely monitoring space to track potentially dangerous asteroids. So far, we have found more than 35,000 asteroids whose orbits bring them dangerously close to Earth. But if one was on a collision course with us, what could we do? To answer this question, an international team came up with the first planetary defense mission: DART to hit the asteroid and Hera to gather data after the impact. Knowing there are so many asteroids that could be a danger to us, how did we pick one to explore? The asteroid that DART hit and that our Hera spacecraft will now visit is called Dimorphos. It's a small asteroid, about half the size of the Eiffel Tower, but if it impacted Earth, it could devastate a small country or city. Dimorphos orbits a larger asteroid called Didymos, which Hera will also visit. Together, the two asteroids form the Didymos system. Here are some of the reasons why scientists decided to explore the Didymos system among all the asteroids out there. The two asteroids are not a real threat to Earth, so nudging one of them wouldn't accidentally set it on a crash course to Earth. The system passes relatively close to Earth, so they are not impossible to get to. The 150-metre diameter of Dimorphos is important. We know about 95% of all near-Earth objects larger than 1 kilometre in size, but the majority of smaller asteroids are yet to be discovered, despite their city-killing potential. Since Dimorphos orbits Didymos, we can easily see any changes in its orbit from Earth. So, what are we expecting to see on Dimorphos? We asked one of our experts, Patrick Michel, the principal investigator of the Hera mission, to find out more.
So what we expect to find on Dimorphos? That's a big question. Actually, we don't really know, because the DART mission by NASA made an impact on Dimorphos, and based on the current data that we have from this mission, there are different solutions. So Dimorphos may host a crater whose size is unknown, or it could be completely reshaped.
Prior to DART's impact, it took Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid. Since the collision, astronomers have found that the spacecraft's impact altered Dimorphos' orbit around Didymos by 33 minutes, shortening the orbit to 11 hours and 22 minutes. The mission was deemed a large success, but to learn more about these asteroids' physical properties and DART's impact outcome, we need to visit them. Initially, we thought that when DART crashed into Dimorphos, it would create a big impact crater, potentially the first one ever made by humans. But now, scientists think there might not be a crater on Dimorphos after all. More recent simulations suggest the impact might have completely changed the asteroid's shape. Scientists estimate that around 8% of the asteroid's mass was shifted around its body, and 1% of the entire mass of Dimorphos was thrown into space, some of which may reach as Hera turf as small meteoroids.
So the DART impact generated a lot of ejecta, a lot of material that is still escaping from the system at tens of thousands of kilometers from Dimorphos. And it may be that some small particles eventually reach Mars or the Earth, but in the form of shooting stars, like what you see in the sky during the night, so with no risk. We don't know what it looks like now, so there's going to be a lot of surprises, and I'm so excited because in 2 years we will have the answer.
Crater or no crater, we need to go back to Dimorphos to study the aftermath of the impact. This will help us turn the DART deflection experiment into a well-understood, repeatable technique that might one day be needed for real. So, we know it will take us 2 years to reach the asteroids after launch, but how do we get there? On its way, Hera will make a swing-by of Mars in March 2025, borrowing speed to help reach its destination. In the process, Hera will get as close as 6,000 kilometres from the surface of the red planet, closer than the orbits of the 2 Martian moons. Hera's trajectory will be tweaked so that it can train its science instruments onto Mars's smaller moon Deimos for less than 1,000 kilometres away, a practice run for when it reaches the asteroid system, while also observing Mars itself. A second deep space manoeuvre in February 2026 will line Hera up for arrival at the Didymos system. Hera will have an impulsive rendezvous with the system in October 2026, meaning it will be captured by their gravity and begin to orbit. Didymos' gravity is estimated to be around 40,000 times weaker than Earth's, while Dimorphos' is approximately 200,000 times weaker. This is so low that Hera must orbit around their common centre of gravity at very low velocity to remain captured. To maintain the optimal distance for studying the asteroids, Hera's orbit will need regular adjustments, otherwise the spacecraft could gradually drift away from them. The possibility of Hera touching down on one of the poles of Didymos at the end of its mission is being considered. Although it has not been specifically designed for landing, it could descend towards the surface. However, once on the surface, Hera will no longer be able to communicate with us on Earth, effectively bringing the mission to an end. What types of technology do we need to inspect an asteroid? Although Hera itself may not land on the asteroid, it is packed with new technologies which will allow us to study the asteroid in extraordinary detail. Hera carries a total of 12 instruments to explore the Didymos system. It has a state-of-the-art camera which will take detailed pictures of the asteroids, a laser altimeter which will create a map of the asteroid's surface, a camera which can look at the asteroids in different colours of light to find out exactly what they're made of, a radio science experiment which can use radio waves to figure out the mass and gravity of the asteroids. To explore Dimorphos and Didymos, Hera doesn't go by itself. Instead, the spacecraft carries 2 shoebox-sized CubeSats that resemble terrestrial drones, able to fly closer and take more risks and eventually even land, a world first.
This is the first time that we send a spacecraft equipped with 2 CubeSats that will do deep space exploration of an asteroid. And the reason why we bring this CubeSat is because we want to go at very close proximity of the asteroid, and we don't want to pose any risk to the main spacecraft. And these 2 CubeSats will contain their own instruments, and for the first time, for instance, we'll be able to probe the internal property of an asteroid, which has never been done so far, and that's on the Juventas CubeSat. On the second CubeSat, Milani, we'll measure the mineralogical composition of the asteroid and detect whether there is still dust around the body.
The 2 CubeSats, called Juventus and Milani, will get up close and personal with the asteroid. Juventus will use radar, sending out radio waves that will bounce off the asteroids and come back. By measuring how long it takes for the waves to return, we will be able to tell how far away the asteroid is at any given point and even what shape it is. More importantly, it will allow us to explore what an asteroid is like on the inside for the first time. Is Dimorphos a rubble pile or a monolith covered with pebbles and gravels? Once it has inspected both asteroids, it will then descend to Dimorphos' surface to take detailed pictures of the surface features, including hopefully the exact spot of the dart impact. Once on the ground, it will use a gravimeter to increase our knowledge of the gravity field of the asteroid. The other CubeSat, Milani, will measure the mineralogical composition of the asteroid and will analyse any surrounding dust. Later on, it will also attempt a landing on Dimorphos. Its onboard instruments will gather valuable data on the landing and any subsequent bounces to give insights into the surface properties of the asteroid. If Milani lands safely, its Vista instruments will analyse the dust on Dimorphos' surface. By the end of the 6-month exploration by these 3 spacecraft, scientists will have a better understanding of the delicate art of asteroid deflection, and asteroid impacts will become the first avoidable natural disaster. At first glance, an asteroid is just a tiny dot of light in the sky. We require more observations to see if it is a real threat. Planetary defence is a global problem, and therefore we need to be able to work together with other space agencies to protect our planet, and Hera is the perfect demonstration of that.
Right, so there we are. So, yes, we don't actually know the exact composition of Dimorphos. So, dealing with any asteroid threat, it's going to need a range of different solutions depending on the composition of the asteroid. Because if it's a metallic asteroid, it's going to require a completely different approach to something like Dimorphos, which is either just a rubble pile loosely held together under gravity, or it's a solid bit of rock. But in either way, it will react very differently to an iron nickel asteroid, for example. I would think that you'd have to hit a nickel iron asteroid a lot harder because it's going to have a lot more mass. Probably it's a lot denser. So, but this is only the first step in planetary defense, and we do have to do this because, as the video depicted, the Tunguska impact or near impact, because it exploded midair, of 1908. Chelyabinsk in 2012 over the Russian city of Chelyabinsk. I mean, that injured over 1,000 people, mainly by flying glass. So these impacts do happen, and we need to be prepared for them. We're just lucky so far that there hasn't been a major strike on a city, which could be absolutely disastrous, as we know. And the worry was during the Cold War that an asteroid strike on a city might be mistaken for a nuclear attack and it might trigger World War III. So these things are very dangerous in lots of ways. So we need to develop a comprehensive defensive strategy for the whole planet. And this is truly an international effort. NASA smacked it, Europe looks at it. It's an international effort, and more countries need to get involved. And there, in my opinion, there should be a central budget for this that countries pay into, because it threatens every country in the world. An asteroid could come down anywhere, so there should be a central fund for missions like this, because it's just so important. And I think, in light of the recent announcement last week that was it last week or the week before? Recently, anyway, that the asteroid which finished off the dinosaurs was not alone. That in fact there were 2 asteroid strikes on the planet. One of them, as we know, landed in what is now the Yucatan Peninsula in Mexico. The other one splashed into the sea off the west coast of Africa. And they discovered the crater in 2022, and it's just been confirmed that it is in fact the crater of a big asteroid. Now, we don't know whether these 2 events were related 66 million years ago. We don't know how far apart they occurred in time, but it could be that we were looking at one body that split into 2 and impacted in different places on the Earth's surface, or one strikes the Earth and then X amount of time later, and we don't know because we can't pin down the dating of these events accurately enough. Sometime later, another body smashed in. But that makes no sense to me, that they don't think that they were very widely separated in time, these 2 events. It makes more sense to me that it was one body that split up. Sorry, Michael, are we keeping you up?
Sorry.
You're drifting off there.
Sorry.
Get yourself a cup of Horlicks and get it. Yeah.
It's nap time, isn't it?
This is nap time. Yeah, sorry, we didn't mean to disrupt your nap time. So, but anyway, so it makes the strike that finished off the dinosaurs even more alarming. That the body was, if it's true that it was one object, that it was a lot bigger than we thought.
That's true.
And this could happen at any time. Now, we have mapped 35,000 asteroids that could at some point in the future pose a danger to the Earth. But it's the ones we don't know about, obviously, which are the dangerous ones. And I think the latest estimate is we found about 80% of all the asteroids that are going to cause some damage to the Earth in the future, potentially. But that leaves 20% that are still undiscovered. And we don't know where they are, how big they are. We don't know anything about them. They could suddenly appear one day out of nowhere, especially if they come from the direction of the sun. We wouldn't have a chance of spotting them until it was too late. So planetary defense is a worthwhile expenditure of everybody's money, and we'll just have to see what comes out of Hera's observations. And as they said in the video, it is innovative. It is carrying these 2 CubeSats that are going to make close-up measurements of the asteroid and find out everything about it that we can, because we know very little about it. Mm-hmm. Do you remember when we watched the impact? It was absolutely amazing. Absolutely amazing event.
Yeah.
But we don't know about the composition of Dimorphos, so we'll have to wait and see. Daz, any thoughts?
Well, as you said about the composition, I mean, it's striking that Bennu and Ryugu
yes,
look very, very similar. They're just basically, they look like piles of rubble.
They do.
And because when the DART mission flew past the bigger comet, the bigger asteroid, you could see that was also exactly the same.
Yeah.
So
we can see it on the screen now. Look.
Yeah, I mean, as you can say, as you were saying, these aren't the solid ones. that we're picking off. So, but it's more. I mean, what's going to happen if one of these enters the atmosphere? Is it's going to break up, and it's going to be probably hundreds of meteorites. Whether or not they reach the Earth, I mean, it means it could all burn up, give us a nice light display, or it means we're going to get hundreds of meteorites hit the ground. Depending, we don't know what sizes they're going to be.
No,
But this is something, as you said,
unknowns.
yeah, this is all to do with planetary defense. There are other missions that have been looking at it. I mean, the DART wasn't the first time we hit a asteroid.
No.
We've been doing it for quite a few years now, with different results, and then going back and looking at what's actually happened. So, but yeah, it's something we need to know. I mean, planetary defense, as you said, we just don't know when one of these things is going to become a threat.
Yeah.
And as you said, if it comes from the sun, we're blind.
Yeah.
Until it's almost too late. So yeah, we need as much information as we can. Yeah, and of course, as you said, you were talking about it last Tuesday that they've analysed. I think you were talking about Ryugu or the Bennu samples, and they're a mixture of lots of things. I mean, some of these are considered to be. I mean, Bennu, when they sort of like used, was it sonar or? But they think it was sort of like honeycombed. It wasn't actually a solid mass.
They had a ground penetrating radar. Yeah.
Yeah, that's right. Yeah. So we need to know as much as we can about it. It's the really solid ones we've got to look at. And of course we've got Psyche. That's on its way out to Psyche 16, which is considered possibly to be the core of a protoplanet.
Yeah.
And it'll be so interesting to see what we find there.
Definitely.
The more information the more information we've got, hopefully the more prepared we could become.
Okay, so let's go over to the European Space Agency coverage for a moment, and I see that they've started the coverage of the launch. It's 14 minutes and counting to the launch. So we've got a little way to go yet. Of course, we're lucky to see this mission launching at all today, because it's going to launch on a SpaceX Falcon 9, and the whole Falcon 9 fleet is grounded after the recent anomaly where the second stage of a Falcon 9 failed to do a deorbit burn correctly and ended up landing in the ocean way off its intended point. In fact, it ended up just off the coast of New Zealand. So the Federal Aviation Administration, the FAA, who are very much being cast as villains these days, are doing an investigation. But they have allowed this launch to go ahead today, and only this one, because the second stage of the Falcon 9 is not going to do a deorbit burn. So the same problem won't occur. So this one is going ahead. However, we still have no word about the launch of Europa Clipper, which incidentally has now been postponed from Thursday to Saturday because of the incoming Hurricane Milton, which is going to reach Florida on Wednesday. So just make a note of that. Our live coverage will now be on Saturday instead of Thursday. They will need a license from the FAA because it uses a Falcon 9 second stage, even though, of course, we know that the Falcon Heavy comprises 3 Falcon 9 rockets stuck together, as it were. There's a bit more to it technically than that, but that's basically what it is. And so the FAA will be licensing that one. So the good thing is that SpaceX have told the FAA they will have their final report on the recent anomaly ready for the end of the week. So hopefully the FAA will at that point grant a license. Bit of a shame because we do want Europa Clipper to launch. We want to get that on the way to Jupiter's moon Europa. And anybody remember the is it 2029? I think it arrives at Jupiter.
That's the plan. Yeah, that's the plan.
Yeah. So that's another exciting mission coming up. The mission to study Jupiter's moon Europa, which, as you may know, has an underground ocean which contains more water than all of Earth's oceans put together, we think. And the Europa Clipper mission is going to investigate it. It's already is going to be hot on the heels of the European Juicy Icy Moon Explorer, or JUICE, and that is going to investigate not just Europa, but Ganymede and Callisto as well. And so we've got 2 spacecraft which will shortly be on the way to the Jupiter moon system to investigate its moons. It's exciting stuff, isn't it, guys?
Yep, definitely.
Yeah, it certainly is. I mean, of course, you were talking about the licensing of this flight, but of course, if there's just this one, so there are other missions that are going to still be affected by this. There's, I think, there's one Starlink, but also there's the UK's OneWeb, which is supposed to launch tomorrow. So that could end up being delayed. And then, of course, like you said, we've got Europa Clipper, which we definitely need to get on its way. It's fingers crossed and everything gets sorted out. It's a bit of a mess at the moment with the FAA and basically space rockets it all together. I mean, the Vulcan, that wasn't a perfect flight, but they're acting as if it was a success. When you've basically got an engine blow up, you think, but according to I think we've discussed this before, Andy, that there's three ways that a rocket can be certified. If it's a fully NASA mission, NASA have the say. If it's basically ULA, because as we said before, they said, oh, sorry, I didn't mean to do that. If it's a ULA mission, it's basically the Department of Defense, because that's what the whole ULA was set up for. So they have the final say. And then, of course, the FAA deal with commercial. And that can even be if NASA use a Falcon 9, they become a customer then they fall under the jurisdiction of the FAA. So it swings and roundabouts, but we'll see how it goes.
Yeah, let's just drop in on the countdown here. Nice. And it's now 9 minutes to lift off.
Okay.
So let's just get that back. 9 minutes. Lot could happen in 9 minutes, as we know from the past, though.
Yeah.
Weather's looking good, isn't it?
The weather is looking, it's looking reasonable, isn't it? Don't see any problems.
It's acceptable.
Yeah, absolutely.
Within acceptable parameters.
Okay, so while we're waiting for that, just a couple of things. We talked about the Europa Clipper mission. Well, tomorrow night on Space Oddities, on our usual Tuesday live stream, we will be discussing the Europa Clipper mission. We'll be telling you all about the spacecraft, all about Europa itself, and what it's all about. So don't miss that tomorrow. And then on Saturday, as I said, we'll be bringing you live coverage of the launch of Europa Clipper, postponed from Thursday because of Hurricane Milton, which looks really, really bad, that hurricane coming into Florida. So we hope everybody in Florida is going to be okay. So that's what we've got lined up for you this week. Michael, do you want to tell our viewers about next week?
Next week, Tuesday. Is it next Tuesday? Yes. Yeah. We have Robin Huber from the Shetland Space Centre, otherwise known as Saxon Space Centre, to talk about the Space Centre and what's coming up with launching rockets from there. It will be the first, very soon, it will be the first vertical launch from the UK, from Saxon. So we're looking forward to speaking to Robin on the 15th.
Absolutely. So we'll look forward to speaking to him next week, because we've been following the story of Saxon for a long time now,
Yeah.
And it's frustrating that the first launch from Spaceport Cornwall was a failure. So we're hoping for good things from Saxaboard.
Yeah, definitely. Yeah.
But I think in terms of customers, there seems to be a lot more interest in Saxaboard than there is in Spaceport Cornwall.
Yeah, I think so. There's a lot more interest in low Earth orbit rather than what the Virgin Orbit could achieve.
Yeah.
Things like communication satellites. But I know there's plenty of them up there now, but I think there's more interest in that from a vertical launch provider.
Well, I think the thing is that from Saxaboard, it's just easy to put rockets into a polar orbit.
Yeah, exactly. Yeah,
which is the advantage of it, of course.
Yeah.
So lots of countries are interested these days in launching into polar orbits,
Yeah.
which traditionally has not been a type of orbit that has been that popular, because really the only people that could put things into polar orbit were the Russians from the north of Russia, from Kazakhstan where they are.
Yeah.
This opens up polar orbits to Western countries. And this is why there's a lot of interest in what's going on at Saxaboard. They did have that mishap recently with the German company, Rocket Factory at Augsburg, whose rocket exploded when they were testing the engines on the pad. And an engine exploded and the whole rocket was destroyed. But this is spaceflight. This happens, and this is the whole point of a static fire, to test whether things work. And on this occasion, they didn't. So that delayed RFA getting into space, but they'll be back.
Yeah, definitely. Robin is actually based in Germany, even though he's a main player at Saxaboard. So it'd be good to see international cooperation.
Absolutely, and of course it's going to rejuvenate the Shetland Isles in terms of its economy.
Yeah.
The effect on the Shetland economy is going to be fantastic.
Yeah.
And perhaps I'll start putting on more ferries there.
Yeah,
certainly. And even the odd hovercraft.
Yeah.
So
the tourist industry would, I'm sure,
absolutely
take off if you forget the pun.
Yeah. And
it'll give a boost to the islands, won't it? And what we need also really is, I think what we need to explain is that at Saxaboard they're doing vertical liftoffs like we're going to see here today. And when we mentioned Space Port Cornwall, they were doing the horizontal ones where the rocket is actually slung underneath, say a 747 or something, and then it's fired horizontally, and then it builds up speeds, then lifts up into orbit. And I think most people prefer the direct route, the horizontal route.
Well, it's more reliable, isn't it?
Yeah, and because it's not that. Horizontal isn't new because they've been doing it with the Pegasus system for years. The American Pegasus.
Vertical launch is a lot more, fascinating to the general public. Whereas, when they see a title saying launching into space, they want to see a rocket taking off. They don't want to see an airport taking off.
Right. Sorry, Daz, can we just go over?
I'm there on your screen.
Yeah. Oh, we're going on.
We're coming up on T-minus 3 minutes. Strongback is in the countdown configuration. It's about 1.5 degrees away from the Falcon 9. Waiting for next is completion of liquid oxygen loading on the first
stage. 1 LOX load is complete.
Right on time. So at this point in the countdown, the first and second stages are nearly fully loaded with the 1.1 million pounds of fuel and liquid oxygen. We have loaded all of the fuel on first and second stage. Liquid oxygen is now complete on the first stage. The last major event will be T-minus 2 minutes when we finish loading liquid oxygen on the second stage. And you can see right there the cold, chilled skin of the second stage. There's the warm Florida air moving by it. We're seeing the condensation of the moisture in the air. Everything continuing to look good as we come up on T-minus 2 minutes.
Stage 2 LOX load is complete.
And there's that call out that liquid oxygen loading is now complete on the second stage. Now that means that propellant loading is complete on Falcon 9. And that's over 1.1 million pounds of propellants now loaded on the vehicle. All systems remain go for launch. SpaceX ground computers are now draining propellant out of the lines that go up to the strong back onto the second stage. And there you can see that venting happening there on your screen. Now this creates a white cloud, which is pressure from the ultra-cold liquid oxygen line that's being vented there.
Ground gas closeouts.
And again, when that cold liquid oxygen gas meets the warmer ambient air there, it creates that condensation that you can see there on your screen. Now, the first and second stage computers on Falcon 9 will execute stored programs to prepare the rocket for flight, leading to the ignition of the M1D engines at T-minus 2 seconds and liftoff at T-minus 0.
Falcon 9 is in startup.
Good.
With that call out, the Falcon computers are running the final sequence for launch. First and second stage tanks are beginning final pressurization for launch. All systems are go. Let's listen in to terminal count.
LD, go for launch.
As Falcon 9 transports the European Space Agency's Hera spacecraft into space.
Go Hera. Fingers
Go
crossed.
Hera.
30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, engines full power, and liftoff. Go Hera, go Falcon, go SpaceX.
Fantastic. It's away.
Yeah.
Hope it stays away.
Vehicle is pitching downrange. Stage 1 propulsion is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 40. After clearing the tower, we begin to tilt or gimbal the engines. That initiates a roll maneuver you might see on the Stage 1 camera view, although it's kind of cloudy. But this enables the vehicle's antennas to stay in the best position for communicating with the ground. We are into throttle down now in preparation for max dynamic aero.
Falcon is supersonic.
Faster than a speeding bullet, we're supersonic on Falcon 9. Waiting for the call out from GNC of Max Q.
Max Q.
Right on time. We're through the period of maximum pressure on the vehicle. The Merlin engines are back at power, and we're out of the throttle bucket. Now, from here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and that's resulting on less loads on the Falcon 9. 90 seconds into flight, the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth and getting into orbit. We've heard the call out for MVAC chill. That's a bleed valve on the second stage engine. That's performing the final chill prior to second stage engine ignition. All's looking good with the first stage trajectory. We're coming up on T plus 2 minutes. Views from onboard the camera mounted on the inner stage of Booster 1061. Now we've got 3 events that'll be coming up in just under 30 seconds. Main engine cutoff, the 9 Merlin engines will be throttled down and shut down. Then we'll get stage separation and then startup of the MVAC engine on its first of 2 burns on the second stage. We've begun throttling down the Merlin engines.
Main engine cut off.
Call for Miko.
Stage separation.
Okay.
Successful stage separation.
MVAC ignition.
Great.
Great.
MVAC ignition and warp on power on stage 2. Coming up will be fairing deployment. And for the first stage, as we saw it in the background, farewell 1061, and we thank you.
Oh.
Are they not landing the booster then?
As we continue climbing out of Earth's atmosphere,
Doesn't sound like it.
we're waiting for the right time when we can open up and deploy the fairing. That should be coming up in about 10 seconds.
There's nothing on the timeline below, is there?
No, there isn't.
It looks like the
That's the
there
last.
is
There's a camera view as we switch.
The first stage is
You
not
can see
being
Hera
recorded.
inside the two halves of the fairing.
Fairing separation.
Wow.
And successful payload fairing separation. As we mentioned earlier, the fairing halves have supported multiple missions. One half has flown 12, now 13 missions, and the other had previously flown 18.
Oh, wow.
And those fairing halves will come back down to Earth. They're guided by cold gas thrusters and then parachutes or parafoils.
Falcon is on a nominal trajectory.
They'll deploy and they'll be recovered by our recovery vessel, Doug. Jesse, T plus 4 minutes, 23 seconds. Everything continues to look good on Falcon 9 with Hera.
Thanks, John. Yeah, everything's looking great. We got some awesome views here on your screen. What you're looking at is a view of the MVAC engine on the second stage with a beautiful view of Earth in the background.
STS has safed.
Now, we are currently in the first of 2 planned MVAC burns for this spacecraft. And we have separated for the first stage from the first stage. As we mentioned earlier, we will not be recovering the booster as we usually do. Now, typically we would land the booster either on a drone ship or back on land, but due to the performance, the additional performance required to deliver this payload to to an interplanetary transfer orbit, we will be not recovering the booster today.
Yeah.
And what you are seeing, again, is the MVAC engine. The MVAC engine is optimized for the vacuum of space and has about 220,000 pounds of thrust in vacuum.
Okay.
Again, this is the first of 2 burns. The 2 burns.
So there we are. So that's a
Oh.
Oh, we lost Andy.
Oh, so
We
that's
lost Andy.
yeah.
Yeah, so that was a successful launch, which is nice.
Yeah.
Yeah, it was very nice. A lovely launch. It's a shame they're not recovering the booster, but as they said, they needed the extra performance. It's used all its fuel to push it into a higher, basically higher orbit, so that it can actually then escape Earth's gravity when they actually send the satellite, the interplanetary launch, where they'll launch the satellite up into space, and then it'll be off to do its job with 2 years travel before it gets there. Now we were talking about licensing earlier. The only reason, one of the reasons that the FAA allowed this launch is that the second stage will not be doing a boost back burn, and of course that was the problem that they had an anomaly with the boost back burn on the other one. So this is why it's basically just stopped right. But yeah, so the booster is going to be expendable. They're going to recover the fairings, and onwards and upwards. It's on its way.
fantastic.
Yeah, I think in regards to the booster, it's good that it's done so many missions, as they said, and then thrown it away after a long service. So,
Yeah, absolutely. And the thing is as well that at the end of the day, as they said, the interplanetary trajectory also means that it's usually a couple of orbits before they actually detach the spacecraft from the second stage of the Falcon.
Okay.
So we're not going to hang around for that because we don't know exactly when it will be occurring.
Yeah.
But usually they check out the spacecraft while it's in orbit and go through a complete systems check before detaching it from.
It's just gone into CECO 1, so that's the second stage cut off.
Right.
So it's going into a coast stage before they will actually do a second burn.
Yeah.
Just to send it on its way. So.
So there we are.
Yeah.
So I think we will draw things to a close for this afternoon. Thank you so much for watching. Don't forget our special on our Tuesday live stream tomorrow night at 8 o'clock BST. We'll be looking at the Europa Clipper mission in some depth ahead of its launch on Saturday. And don't forget the launch has now been postponed from Thursday to Saturday because of the encroaching Hurricane Milton. So we hope you can join us for our Tuesday live stream tomorrow at 8 o'clock BST, or 2000 BST, I should say, here on Space Oddities, when we'll tell you all about the Europa Clipper. We'll have the usual news. We'll have Roger Sky news. We'll have our viewers gallery as always. Daz will tell us all about what's been going on the sun this week, which I think we can sum up in one word: disappointment. And so we will hope to see you as usual on Tuesdays tomorrow. But from all of us from at Space Oddities this afternoon, we bid you a very good afternoon and thank you for being here. We do appreciate it. If you could leave a like on the video, that would be even better. And thank you so much. All right then, take care everybody, and we'll see you soon.